3.1 Derivative of a function. So by definition, the derivative of the function f with respect to the variable x is the function f prime whose value at x is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So hopefully right now you're thinking that you've seen this before. Okay, you saw it in chapter 2, section 4, the last section that we did, except instead of x's, we had a's here. Okay? In this chapter, we're going to introduce to you what's called the derivative. And we are going to find the derivative by using the same method that we used to find the slope of the tangent line. Okay? So the process of finding the derivative of a function is called differentiation. A function is differentiable at x if its derivative exists at x. A function is differentiable over an open interval if it is differentiable at every point in the interval. Okay, copy these notes down. I'll explain more when we get to the example. The derivative of y equals f of x at x is the slope of the tangent line at x, comma f of x. This is also the slope of the function y equals f of x at x. And remember that slope refers to the rate of change of y with respect to a change in x. Okay, so here you're seeing the relationship between this new word, the derivative of a function, and slope of the tangent line, okay, which you've not only started hearing now in this class, you've heard of slopes and tangent lines in your previous math classes. Notation. So you might see a numerous amount of notations for the derivative. So we have y prime, very basic, dy over dx, okay, dy dx, or the derivative of y with respect to x, f prime of x, df dx, or the derivative of f with respect to x, and the derivative of f at x. More commonly are these three. Okay, so that's why I put these three down first, but go ahead and copy them all down for your notes. Okay, so let's do an example. It's going to be very similar to 2.4. So to get started, we need to start with that definition. Okay, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Quick reminder that before we do this, we need a couple of things. Okay, we're going to need f of x plus h. And we are going to figure this out the exact same way we figured it out in 2.4. So we're just going to plug this into the function x squared minus x. So x plus h squared minus x plus h. Okay? And we actually already know f of x is just x squared minus x. Okay? So let's go ahead, and I think we have everything that we need to know. So let's continue. So f prime of x is equal to the limit as h approaches 0. Now we have this x plus h squared minus x plus h minus, now we're going to plug in the function. Do not forget to plug it in using parentheses, x squared minus x over h. Please do not forget that you should apply these parentheses because this negative will be distributed. It applies to both the x squared and the negative x. Okay? Do this in your head. Plug in 0. So you get h squared. 0 plus h. So you just get h squared minus h minus 0. Okay? Oh wait, no, we did that wrong. Or I did that wrong. So I had to plug it into h, not x. I accidentally plugged it into x, but you plug it in for h. Plug in 0 for h, you get x squared minus x squared plus x. So you should get 0 over 0 is the point I was trying to make. Okay, so we know that. So we're going to have to do some algebra. Hopefully you're thinking expand and multiply. So not just expand x plus h times x plus h. That alone won't help, but multiply it. So you get x squared plus 2xh plus h squared. Let's distribute. So we get minus x minus h. Let's distribute for the second one. And we get minus x squared plus x all of it over h. So f prime of x is equal to the limit as h approaches 0. Now let's start seeing what can cancel out. So that's been common in a lot of problems. X squared minus x squared, and then we also get negative x with a positive x. I think that's it. So we get 2xh plus h squared minus h over h. And this is looking familiar. I hope it's not a problem that we've already done. So the limit as h approaches 0, 2x plus h minus 1. Ooh, I think it was in your homework actually. We get 1 over 1. So we get f prime of x is equal to the limit as h approaches 0 of 2x plus h minus 1. So we have 2x plus 0 minus 1, which is just 2x minus 1. Okay? So that's the derivative. And it kind of makes sense that although we've never done this problem exactly because you haven't done anything that required derivatives, it makes sense that it's very familiar to one of your homework problems because, like I said, this is very, very similar to 2.4. Okay, so 2.4, you guys were using this method to find the slope of a tangent line. Okay, so now we're calling this the derivative. Okay, so I added on the part B. Find the equation of the tangent line to the graph of f of x equals x squared minus x at the point 3, 6. So notice that in part A, I never gave you a point. You just found the derivative. You left it as a function 2x minus 1. You can't really find the equation of the tangent line without a point. So I kind of have to give you a point or an x value. You need an x value or a point to find the equation. And we are going to use the y minus y1 equals m times x minus x1. So the point slope formula. And this one's very easy because you got the x and the y, although it wouldn't be too hard if you were not given the y. So now we need to, before we can plug in the slope, we need to find the slope. So if f prime, so let's do again a little side note that we need f prime of 3. So we need the slope when x equals 3. Okay, we're going to use the derivative that we just found, and that was 2x minus 1, so that we can figure out that we get f prime of 3. Whoops. I wanted to color code. F prime of 3 is equal to 2 times 3 minus 1. So we're going to plug in 3 for every x value, and we should get 5. Now we can finish this. So we get 5 times x minus 3. Remember, we can leave this like this. We are done. We can stop here. Okay, but we can also add 6 to both sides, or after I distribute this. Okay, so I'm going to get 5x minus 15. So when we add 6 to both sides, we should get 5x minus 9. Okay, so that should be the answer. Okay, so graphically, what does that look like in a graph?